Hello there, so welcome back to the channel and welcome to Excel Island, where the goal and objective of this live stream is to learn and master Python over the next 100 days. Today is day 57. We're on the course Introduction to Data Visualization with Seaborn, Seaborn is the powerful Python library that makes it easy to create informative and attractive data visualizations. We're actually learning all about Seaborn in this course. And this particular course actually contain 4 chapters. So in the whole career track for this data analyst in Python on the DataCamp platform, we have 15 courses. Within those 15 courses, there are like 2, 3, or 4 projects we need to complete after learning a couple of courses. So we are on the eighth course right now, which is Introduction to Data Visualization with Seaborn. So without further ado, we're just going to continue from where we stopped yesterday. We're actually learning how to visualize to a categorical variable and a quantitative variable, which are two different variables in data analysis. So I'll just start sharing my screen so we can continue from where we stopped on day 56. So, so if you look at introduction to data visualization with Seaborn, I'll just click on it so we can continue immediately. So welcome back. So if you're looking to upskill yourself in data analysis, I did a couple of live stream on Power BI and SQL also. You can just go to the live stream tab of the channel and check it out. So this was where we stopped 2 days ago. We actually looked at the cat plots syntax for visualizing bar plots and a couple of other plots. So I'm just going to continue from here, which is creating a box plot. So we've covered counting plot or bar plots, count plots, bar plots with percentages. I've also learned how to customize bar plots rather. Let's look how we can learn today. Probably we'll look at box plots. We'll learn how to create and interpret a box plot. We'll learn how to omit outliers, adjusting the whiskers. Then we'll also look at point plots. Let's see if we can do a couple of these in today's lesson.
Hello! In this video, we'll learn how to create a new type of categorical plot, the box plot. A box plot shows the distribution of quantitative data. The colored box represents the 25th to 75th percentile, and the line in the middle of the box represents the median. The whiskers give a sense of the spread of the distribution, and the floating points represent outliers. Box plots are commonly used as a way to compare the distribution of a quantitative variable across different groups of a categorical variable. To see this, let's look at this example. The box plot shown here uses the TIPS dataset and compares the distribution of the total bill paid per table across the different days of the week. From this box plot, we can quickly see that the median bill is higher on Saturday and Sunday, but the spread of the distribution is also larger. This comparison would be much harder to do with other types of visualizations. Now let's look at how to create a box plot in Seaborn. While Seaborn does have a box plot function, we'll be using the cat plot function that we introduced in an earlier lesson because it makes it easy to create subplots using the call and row parameters. We'll put the categorical variable time on the x-axis and the quantitative variable total bill on the y-axis. Here we want box plots, so we'll specify kind equals box. That's it. We have a nice looking box plot. Next, we'll look at different ways to customize this plot. As a reminder, cat plot allows you to change the order of the categories using the order parameter. Here, we specified that dinner should be shown before lunch. Occasionally, you may want to omit the outliers from your box plot. You can do this using the sim parameter. If you pass an empty string into sim, it will omit the outliers from your plot altogether. Sim can also be used to change the appearance of the outliers instead of omitting them. By default, the whiskers extend to 1.5 times the interquartile range, or IQR. The IQR is the 25th to the 75th percentile of a distribution of data. If you want to change the way the whiskers in your box plot are defined, you can do this using the whisk parameter. There are several options for changing the whiskers. You can change the range of the whiskers from 1.5 times the IQR, which is the default, to 2 times the IQR by setting whisk equal to 2.0. Alternatively, you can have the whiskers define specific lower and upper percentiles by passing in a list of the lower and upper values. In this example, passing in 5,95 will result in the lower whisker being drawn at the 5th percentile and the upper whisker being drawn at the 95th percentile. Finally, you may just want to draw the whiskers at the min and max values. You can do this by specifying the lower percentile as 0 and the upper percentile as 100. Here's an example where the whiskers are set to the min and max values. Note that there are no outliers because the box and whiskers cover the entire range of the data. Let's now practice creating and customizing box plots.
Okay, so let's see how to create a box plot. Just a second there. Let me just zoom in a little bit. Create and interpret a box plot. So I have my data sets, my Python file already loaded there. So this was what we are using from day 56, this data set of young people survey response. Hopefully we're going to continue with that. So we learned to create a count plot the last time. We also learned to interchange our count plot to make it a vertical. Do you get that? So we also created a new column here in this instance and use it to visualize our two different categories of each data set here. So you can just watch the 56 to understand all what is happening in this Jupyter notebook file here. I'll just continue. It says, let's continue using the student data sets. In an earlier exercise, we explored the relationship between studying and final grade by using a bar plot to compare the average final grades among students in different categories. In this exercise, we will try using a box plot. Look, we'll try using a box plot. Look at this relationship instead. As a reminder, to create a box plot, you need to use the cat plot function and specify the name of the categorical variable to put on the axis, the name of the quantitative variable to summarize the y-axis, the pandas data frame to use, and the type of plot, which is box in this instance. We have already imported matplotlib as PLT and Seaborn as SNS. So we have all of this imported in all our libraries that we need to use. So these are all the libraries we've learned so far over the course of this learning journey. I'll just continue for using sns.catplots and the student data frame to create a box plot with study time on the x-axis and j on the y-axis. Okay, let's see. Specify the category you're doing. Study time order. Okay, these are the order. Study time order. I just say SNS docs box plots. So use SNS the box plot. Let's see. Create a box plot and set the order of the categories. So let's have SNS dot cats plots. Our x-axis is going to be students study time. and the y-axis is going to be G3. So our data frame for this instance is the student data. Then the type of visualization to create defined is going to be a box, plot. Sadly enough, I don't have access to this data sets in my Jupyter notebook. I have access to this young. Let me just check one more time. Student alcohol consumption. This is alcohol consumption, not young people survey. The data that we're working with in this instance is grade about their final grade. So let's just make use of it in this instance here. Let me run the code and see. Voila. We have our, I can see. So these are the different hours. Okay, okay. I say create a box plot and set the order of the categories. Okay, I should set order of categories also. Our order, I want probably from the lowest to the highest. So I'm going to include the other line of code here. Order that's going to be equal to this study time order here. Let's run it again on the code. So you're going to start from the lowest, less than 2 hours, 2 to 5 hours, 5 to 10 hours, and 10 hours and above. So you see it a little bit more. You can just bring it down a little bit so you can see it clearly. Voila. You see, so let's continue like this first. So I think this is better. Let's submit and see. So which of the following is the correct interpretation of this box plots? You can see the study time difference. Let me just switch on my camera real quick. You can see that less than 2 hours, 2 to 5 hours, 5 to 10 hours, and greater than 10 hours. It says, which of the following is the correct interpretation of this box plots? The 75th percentile of grade is highest among students who study more than 10 hours. 75th percentile, more than 10 hours per week. We can see looking at it, the 75th percentile is highest. Oh, there are no outliers plotted for this box plus. The fifth percentile of grades among students studying less than 2 to 5 hours is 5.0, probably 50. The fifth percentile, mm, when you look at this on fifth percentile of grade is highest among students. So fifth percentile of the grades, which is this line here. Could say that is true because you can see here, we say the fifth percentile of grades among students studying less than 2 hours is 5.0. Among students, the fifth percentile is probably above 2 hours, 5.0. The median grade among students studying less than 2 hours is 10. The median grade among students, median, you can see the median here is 10. The median grade is 10. This one is slightly, is close, less than 2 hours. The median grade is 10. If we go for this, let's see. That's correct. So that means the rest of the equation are now actually box plot. The line in the middle of each box represents the median. We know that the line in the middle of each box is the median. This is the interquartile range. This is the first quartile, the median, second quartile, then the fourth quartile. So all other interpretation here are incorrect. Let's continue and see. So omitting outliers. Okay, let's look at how to omit outliers in our box plots. So now let's use the student data set to compare the distribution of final grades, which is their G3 grades, between students who have internet access at home and those who don't. To do this, we use the internet variable, which is a binary yes or no indicator of whether the student has an internet access at home. Since internet may be less accessible in rural areas, We'll add up subgroup based on where the student lives. For this, we can use location variable, which is an indicator of whether a student lives in an urban or rural location. Seaborn has already been imported as SNS and matplotlib has been imported as PLT. As a reminder, you can omit outliers in the box plot by setting the SM parameter equal to an empty string. So to specify what we want the SM parameter to be. So let's use SNS again to create our plots, our data visualization. Our x-axis is going to be, so the internet is going to be our x-axis, and our y-axis is going to be the J3. Our data frame is going to be the student data as usual. This should be our data frame. And our plot is going to be a box plot. Add subgroups. So each box plot is colored based on location. So we want to add subgroups. So I can color each box plot. Do not display the outliers. Ooh. Okay, so we don't want to display the outliers. We can use the sim syntax and specify what we want to omit by. Let's do 1.5, which is the default according to the lessons. Do not display the outliers. I'm missing a subgroup here. So let me just run the code first. Let's see what we are going to have. Oh, this. I'm not supposed to put anything here. Let's run the code again. Ooh, I'm not getting the width syntax. So I need to mention the lower range and the upper range. Okay, let's get up on this error. But the mistake is coming from the width syntax here. No, from the sim syntax rather. Okay, we are supposed to set this on empty string to show that we're not displaying any outliers. Now let's run the code again. Voila. But I'm missing a step. If I try to submit, I should get this error. Check your, did you specify the argument you? So I didn't specify that. So I need to miss this location. Add subgroups for each box plus to color location. Okay, how do I do that? Let's see. So I'm missing the EU location. Okay, EU location. After my kind, so that's what this EU line of code is for. Let's run the code again. I'm missing a comma here. Let's run it again. Voila. So you can specify that the location is showing where each student are, urban and rural. You can see. So let's submit and see. Voila. You can see those in the urban location, those in the rural location. You can see we've omitted the outlier. Such that the median grades are quite similar between each group, but the spread of the distribution looks larger among students who have internet access. The spread of the students looks larger among students who have, you can see, those who have internet access, the spread is kind of high. The median grades are quite similar. They both have similar median grade, you can see, just above 10.0, just above 10.0. Okay, let's continue. Ooh, what is that? Oh, let's continue learning. I just trying to resume back to learn after a couple of break here. So let's adjust the whiskers. In this lesson, we saw that there are multiple ways to define the whiskers in a box plot. In this set of exercise, we'll continue to use the student data set to compare the distribution of final grades between students who are in a romantic relationship and those that are not. We'll use the romantic variable, which is a yes or no indicator of whether the student is in a romantic relationship. So let's create a box plot for this. Romantic, this has been created for us. We're just going to add something to it. So using our x variable as romantic and the student grades as the y variable. Okay, adjust the code to make the box plot whiskers to extend to 0.5 RQL. Because the RQL is the interquartile range. I'm going to add the width syntax here. It's called width equals to 0.5 times the interquartile range, which is 2.0. Okay, let's see. So the width is 2. Let's run the code. Oh, so we didn't get that. Let's get help on the error, which is 0.5. So you say 0.5 times the interquartile range. With that not, won't we need to multiply that by, let's see, okay, let's run the code. So we're still getting an error, you can see. So you don't include the interquartile range syntax there. Oh, let's see, times the IQR. So what is the IQR? So I'm just mentioning 0.5. Okay, I'm supposed to include this in brackets. Let's see, voila. Okay, let's submit and see. Okay, we got it. So we just need to mention the week's value. We know that 0.5 times secretary array is the interquartile range of the value. Okay. Now let's change the code to set the whiskers to extend to the fifth and 9% percentiles, which is 5 and 95. So I'm going to change this width to 5 95th percentile. That's all we need to mention there. Let's run the code. Can see that it's quite different. This is the fifth percentile. This is the 95th percentile here. Hmm, let's see. Now change the code to set the whiskers to extend to minimum and maximum value. So the minimum value is 0, which is, and the maximum value is 100%, which is 0% and 100%. Let's run the code and see. So they are quite similar. Just the same thing, no difference, not small differences. So the median grade is same between these two groups, but the maximum grade is higher among students who are not in a romantic relationship. And the maximum grade is higher among students who are not in a romantic relationship, but the median grade is the same between the two groups. The median grades is the same. So the median value, either you're in a relationship or not, so your median grade is at least above 10.0. Interesting. Okay, let's see what we need to finalize there. So points plots. So there's another thing called point plots. Okay. So we are familiar with box plots, bar plots, count plots. So we've done box plots. We're looking at point plot. Point plot is still the same thing as line plot. Interesting. So let's refresh this page. Ooh, why is the page taking so much time to load? I'm just going to. Yep, it's coming up. So let's look at point plots.
Welcome! So far, we've seen several types of categorical plots, including count plots, bar plots, and box plots. In this lesson, we'll see one final categorical plot, point plots. Point plots show the mean of a quantitative variable for the observations in each category, plotted as a single point. This point plot uses the TIPS dataset and shows the average bill among smokers versus non-smokers. The vertical bars extending above and below the mean represent the 95% confidence intervals for that mean. Just like the confidence intervals we saw in line plots and bar plots, these confidence intervals show us the level of uncertainty we have about these mean estimates. Assuming our data is a random sample of some population, we can be 95% sure that the true population mean in each group lies within the confidence interval shown. You may be thinking, point plots look a lot like line plots. What's the difference? Both line plots and point plots show the mean of a quantitative variable and 95% confidence intervals for the mean. However, there's a key difference. Line plots are relational plots, so both the x and y-axis are quantitative variables. In a point plot, one axis, usually the x-axis, is a categorical variable, making it a categorical plot. You may also be thinking, point plots seem to show the same information as bar plots. For each category, both show the mean of a quantitative variable and the confidence intervals for those means. When should we use one over the other? Let's look at an example using data from the masculinity survey that we've seen in prior lessons. This is a bar plot of the percent of men per age group surveyed who report thinking that it's important that others see them as masculine, with subgroups based on whether they report feeling masculine or not. This is the same information represented as a point plot. In the point plot, it's easier to compare the heights of the subgroup points when they're stacked above each other. In the point plot, it's also easier to look at the differences in slope between the categories than it is to compare the heights of the bars between them. Here's the code to create the point plot we just saw. Since this is a categorical plot, we use cat plot and set kind equal to point. Sometimes we may want to remove the lines connecting each point, perhaps because we only wish to compare within a category group and not between them. To do this, set the join parameter equal to false. Let's return to the point plot using the TIPS dataset and go over a few more ways to customize your point plots. Here is a point plot of average bill comparing smokers to non-smokers. To have the points and confidence intervals be calculated for the median instead of the mean, import the median function from the NumPy library and set estimator equal to the NumPy median function. Why might you want to use the median instead of the mean? The median is more robust to outliers, so if your dataset has a lot of outliers, the median may be a better statistic to use. You can also customize the way that the confidence intervals are displayed. To add caps to the end of the confidence interval, size parameter equal to the desired width of the caps. In this case, we chose a width of 0.2. Finally, like we saw with line plots and bar plots, you can turn the confidence intervals off by setting the CI parameter equal to none. Alright, now that we've covered how to interpret and customize point plots, let's practice what we've learned.
Okay, let's practice how to use customizing point plots. So it says customizing point plots. So let's continue to look at data from students in secondary school, this time using a point plot to answer the question, does the quality of student-family relationship influence the number of absence a student has in school? Here, we use the famrel variable, which describes the quality of a student-family relationship from 1 very bad to 5 very good. As a reminder, we are quite used to Sheriffdeen. So we already imported Seaborn as SNS and matplotlib as PLT. We're going to be using same scenario, same SNS.cat plot, SNS.cat plot. The x-axis is going to be having our farm rail. X is going to be having the farm rail variable, farm relationship variable. While the y-axis is be having the absence variable. So our data is going to be the student data frame. Our kind is going to be a points plot. Points. Then finally, okay, that's all. Let's run the code. Ooh, okay, I don't have a comma there. Ah, voilà, that's why it's simple to visualize the point plot. Guys. So let's submit and see. So add the caps to the end of the confidence level, which size 2.0. Just add the cap size, syntax there. Cap size syntax of 0.2 rather. So you can see there'll be cap size at the top there. So remove the lines joining the points in each category. Just use the join syntax to change it to false. Then it's going to be equal to false. Let's run the code. So it's moved the line joining the points together, the points plus together rather. Let's submit and see. Also, while the average number of absence is slightly smaller among students with higher quality from the relationship, the larger confidence intervals tells us that we can't be sure there is an actual association here. You can see, so we can't be sure if there's an actual association between these two variables. So point plot with subgroups. So let's create a point plot with subgroups. So this time around, I could just easily go back and just copy this last line of code here. So that point plot with subgroups. Let's continue exploring the data set of students in secondary school, but this time we'll ask the question: is being in a romantic relationship associated with higher or lower school attendance? And does this association differ by which school the students attend? Go. Okay, let's find out. So romantic is going to be our x-axis, the romance variable. Then the absence variable is going to be on the y-axis, correct? Color points on the school that attend school. Okay, color the point based on the school that they attended. So the hue We're going to add the new line of code here. U is going to be equal to the school they attend, the variable school. And let's run the code and see. Voila. You can see that. That's pretty straightforward. So let's submit that. So turn on the confidence level for the plot. Turn on the confidence level for the plot. Turn off. Going to turn off the confidence level for the points. So just add this line of code called CI, which is the confidence level. CI is going to be none. Let's run it. Voila. So we just have those plots without the confidence level there. Let's submit that. Since there may be outliers of students with many absence, use the median function that we've imported from NumPy to display the median number of absence instead of the average. So we're actually looking at the average number of absence. We want to look at the median since there may be outlier in the data set. We're going to say estimator cross the median. You can see from NumPy import median. So our estimator here is going to be median. Estimator equals to median. To change the to median. Voila. So that took care of the outliers in the data set there. You could see, let's submit and see. Good work. It looks like students in romantic relationship have a higher average and median number of absence in the GP school. You can see higher average and median number of absence in the GP schools. But this association does not hold for the MS school. You can see the MS school, it just dropped. Whether you're in a relationship or not, the number of absence is kind of low. So that's that on this lesson for today. Oh, we have one more lesson to do. Changing, oh, we're on chapter 4 already. So we've completed chapter 3, which is visualizing a categorical and quantitative variable rather. So I'm moving to customizing Seaborn plots. So in this case, we'll be learning how to customize all the plots we've done so far. Okay, that's interesting. Well, we'll stop here for today. So we've done a lot of data visualization and changing some little stuff in there with basic customizing. So we'll go deeper on the fourth chapter in customizing uh, charts of visualization with Seaborn. Right, so that'll be the end of the live stream for today. So if you find value in this learning journey of Python with me, do well to support the channel by giving the video a thumbs up, hit that subscribe button, and I'll see you on the next video on the channel, on the Oxa Excel video on the channel also. Have a wonderful rest of the day. Bye. So make sure to download the data sets below so you can also practice your data visualization skill also. I also linked all the Jupyter notebook that we've been using so far under the YouTube description so you can have access to all the data sets we've used for each course in each chapter. All right. So bye for now.